Here are the video solutions for NCFE Level 2 Functional Skills Maths. This is section B, which is the calculator section, and this is practice paper number 2. Okay, so let's take a look at the very first question. We want to work out the area. Now, what we've got here is it's an unusual shape, it's an irregular shape, so we need to turn it into a certain number of regular shapes. So what I'm going to do is I'm going to turn it into a rectangle and a trapezium. Now the rectangle, that's nice and easy. It's the length times the width, so 20.4 multiplied by 9.8, and that comes to 199.92 square meters. Now, if you don't know the formula for a trapezium, you're going to have to work out this rectangle here and a triangle. But if you know the formula for the area of a trapezium, then we can work this one out no problem at all. So the formula for the area of a trapezium is half of A plus B times by H, where A and B are the parallel sides. So this side here and this side here, these are the parallel sides. It doesn't matter which one is A, which one is B, and the height is the height of the trapezium, which is this length here. Now the height, H, the height is going to be 18.3 minus the 9.8, and 18.3 minus 9.8 is 8.5. So this is 8.5 meters. So far I've got a half of A plus B multiplied by 8.5. Okay, so A is 7.5 and B is 20.4. So we need to add together the 20.4 and the 7.5, and that is 27.9. So I've got a half of, probably easier actually if you just think of it as 27.9 divided by 2 multiplied by 8.5, and that comes to 118.575 square meters. So the total is simply these two subtotals added together, and that comes to 318.495 square meters. Okay, so for part B, we've been given the formula and we've been told in the instructions, it says it here as well, 3.14. So it's 3.14 times the length. Now the length, L is the length, which is 7. Actually, just double check that. Yeah, that we're calling that the length and that the width. So 7, actually it doesn't really matter because they're both divided by 2. Both are being divided by 2 times 5 divided by 2 times by the depth, and it does say here the depth in meters, and be careful because they've given us this in centimeters, and 80 centimeters, that is 0.8 meters. Remember, to go from centimeters to meters we are dividing by 100, so times by 0.8. And if you're not sure how to type this into your calculator, you can simply type in 3.14 times 7 divided by 2 times 5 divided by 2 times by 0.8. So that is 21.98, and that is cubic meters. Okay, so let's just make a note of that. So that was 21.98 cubic meters. Okay, so we can see that, we're going to have to fill it with bags of soil. This is better value for money. So how many 1.5s go into 21.98? 21.98 divided by 1.5 is 14 bags. So that's going to be 14 bags times by 110 pounds, and that is 1,540 pounds. Now 14 bags, that's going to be 14 times by 1.5, which is exactly 21 cubic meters. So we've still got 0.98 cubic meters to fill. So unfortunately 0.9 is less than this amount, so either we do 2 lots, we need 2 of these, or we just need 1 of these. Well, what is cheaper? It's actually cheaper to buy the 1.5 cubic meter, so therefore I'm going to be adding on to, I'm going to add another 110 pounds onto this. So 1540 plus 110, and that comes to a total of 1,650 pounds. Okay, so on to C. So we just need to think about this logically. So 3 people take 8 hours. Let's just think about if there were 6 people, Now, don't be fooled into thinking that 6 people would take 16 hours. Remember, 6 people would take 4 hours. You double the number of people, you half the amount of time. More people doing the job equals less time it takes to do the job. Now, the problem is it's not 6, it's 5. So how do I go from a 3 to a 5? Well, probably the easiest thing to do is to think about one person. If 3 people take 8 hours, then one person would take 3 times as long. So 3 8s are 24 hours. So therefore 5 people would take 5 times less time than one person. So 5 people would take 24 divided by 5, and that is 4.8 hours. It doesn't say we need to turn this into hours and minutes. 4.8, I'll just put hours, perfectly acceptable. Okay, so a few key things: 75 centimeters between rows, 50 centimeters between a plant, and a gap of 15 centimeters between the plants and the edge of the plot. So let's deal with that last bit first of all. So we can't just plant a potato on right in the corner there. Okay, so these are meters squared, and 50 centimeters, that is half a meter. So we've got to go in half a meter on both sides, and we've got to go down half a meter on both sides as well. So what we can do is let me just half a meter in, half a meter in. There we go. So we can plot potatoes anywhere on these lines or in these lines. Okay, so I'm going to put my first potato right here, and between potatoes was 50 centimeters, so that is 2 lines. So I can put another potato there, 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 and there. But between the rows had to be 75 centimeters. So this is 50 centimeters, so this is 75. So the next row needs to start here, and again, potatoes can go here, 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 and here, and the other 75 will take us to the other boundary, which, oh, sorry, definitely not there, but here, 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 and here. So 1, 2, 3, 4, 5, 6, 7. So there are 21 potatoes potato plants that can be planted in total. Okay, so moving on to part E. So what I'm going to do first of all is work out the mean. So the mean for the Cara potatoes is going to be these values added together divided by 5. Now the total comes to 8.65, and 8.65 divided by 5 is 1.73, and that is kilos per plant. Now the mean for the Desiree, again exactly the same calculation, except it's going to be divided by 4. So that's 6.53 divided by 4, which comes to 1.6325 kilos per plant. So it makes sense to use the Caras because the yield is greater, 1.73 kilos per plant. Now we're growing 20 plants, so what we need to do is 1.73 multiplied by 20, and this is going to give me in kilos, but we want it in pounds. Now to go from kilos to pounds, we multiply by 2.2. So we can either work out that total and then multiply by 2.2, or we can just do it in one big hit. 1.73 times 20 times by 2.2 is 76.12 pounds. So first of all, the type of potato was the Cara, and it was 76.12 pounds. Okay, so question 3a, the only thing we need to do is work out the median volume. So we've got these 7 volumes here, so remember that the median is the middle volume, and it's the middle one when we put them in order. So let's order these values, so there's 60s and 70s, so let's look at the 60s ones first. So 65, 66 and 67, they are gone, and then it's 70, 71, 72, 73. So to find the middle one, chop one off the left, chop one off the right. Do that again. Repeat the process until we've isolated either 1 or 2 in the middle. Since we've got an odd number of values, we'll get 1 in the middle. So the median is simply 70 millilitres. Nice and easy. Okay, so for this one, what do we need to do? Let's... is the manufacturer's claim correct? The manufacturer claims that 300 grams of apples will produce 2/5 of a pint. Well, first of all, 1 pint is 200, so 1 pint is 568 millilitres, so we want 2/5 of 568. So here we're working out a fraction of a total, so we take our total, we divide it by the number on the bottom, and we multiply by the number on the top. So 2/5 of a pint is 227.2 millilitres. So the question is, does 300 grams of apples produce 227.2? Let me just make a note of this up here. So 227.2 millilitres. Okay, so what we need to do first of all is, on this graph, we are going to have to put in a line of best fit. Now this line of best fit is going to go through the middle of these points. So for example, would be a really bad line of best fit, and as with that, it's going to go right through the middle, like something like that. And using this line of best fit, I am now going to go to 300 grams. So go up 300 grams. Now your line of best fit might alter a tiny bit to mine, and it doesn't matter as long as you can show how you're getting this reading. So for me, I'm turning that into 250 millilitres. So 300 grams of apples gives you 250. We only need 227. So the manufacturer's claim is correct. Or you could say it's wrong because it's not 227, it's more than, but I think we can assume that it's more is good. Okay, right, C. So what we know is that the Blitzit juices information says that the weight of juice it produces is 30% of the weight of the fruit. So if we've got 150 grams of juice, that means that 30% of the whole weight of the fruit is 150 grams. So in other words, if 30% is 150 grams, then what is the full weight of the fruit, which is the 100%? Now 30 and 100 are both multiples of 10. So if 30% is 150, then 10% is going to be 3 times less, and 150 divided by 3 is 50 grams. So if 10% is 50 grams, then 100%, that is 10 times more. So it's going to be 10 times by 50, and that is therefore 500 grams. And we can work that out. What is 30% of 500? 10% is 50, 30% is 150. Perfect, we're back at 150, which was our starting point. Okay, so for this question we want to work out the probability that the student is under 19 and preferred juice from the Blitzit. So we want under 19, the under 19 row and the Blitzit column, so that is 4 people. And that is 4 out of a total of what? 16 plus 4 plus 17 plus 13 is 50. So the probability is 4 out of 50. We can simplify the fraction because we've got 2 even numbers, and that can be simplified to 2 over 25. You could also turn that into 4 over 50 into 8 over 100, so therefore call that 8%, or 0.08, that would also be fine. Okay, so this one's quite a challenging question. So first of all, we know that the ratio of pineapple to mango is 3 to 2. So that means 3/5 is pineapple and 2/5 is mango. We're talking in fifths because 3 plus 2 is 5. So we want to work out, well, if we're making 8 litres of smoothie, what is 3/5 of 8? Again, we're working out a fraction of a total, so that is our total divided by the number on the bottom, multiplied by the number on the top, and 8 divided by 5 times by 3 is 4.8 litres, and that is pineapple, and therefore the rest is going to be mango, and 8 take away 4.8 is 3.2 litres, and that is mango. So let's be clear on that. So pineapple, 4.8 litres, mango, 3.2 litres. Okay, so one pineapple gives you 0.2 litres. So if we want 4.8 litres, we're definitely going to be needing more than one pineapple. So how many 0.2s go into 4.8? Let's just split this down the middle. So I've got my pineapple on one side, mango on the other. So 4.8 divided by 0.2, and that is 24, so that is 24 pineapples, and pineapples cost £1.50. 24 times by £1.50, that is £36. Now mangoes, that was 0.08 litres per fruit, so how many 0.08s go into 3.2? And 3.2 divided by 0.08 is 40, so we want 40 fruits, and 40 times by 65p, or let's turn that into pounds and pence, and 40 times by £0 and 65p is £26. So therefore the total cost is going to simply be 36 plus 26, and that is £62. Okay, when Pete goes to buy the fruit, he finds that the pineapples have increased to £1.75. Well, what were they before? They were £1.50. So it's gone up from £1.50 to £1.75. So it's gone up by 25 pence. So £0, 25 pence. Okay, so what percentage has it increased by? So if we're calculating a percentage increase, remember the formula is the difference divided by the original multiplied by 100. So it's a difference of 25p divided by what it was originally before it went up, which was £1.50. So there's our calculation. 0.25 divided by 1.5 times by 100, and we get 16.666. So maybe we want to round that to the nearest whole number, or maybe one decimal place. I don't think the question says, does it? Oh no, it does say one decimal place. So therefore we're interested in the second decimal place, which is above 5. So the first decimal place will round up 1, so it will be 16.7%. Okay, so for question 4a, what we need to do is draw a plan view. Now remember, the plan view, that is the view from above. So if we're looking at a cylinder from above, all we are going to do is see this circular top. So this is a circle with a radius of 1.5 meters, and the center is going to be -3, 2. So remember, we go horizontally and then vertically. So -3, 2, there is the center. So I'm drawing a circle with a radius of 1.5 meters, and this is 1 meter by 1 meter, this grid here. So the radius would take me out to here on this side, and to here on this side. Up above it will take me to there and to there, although what you need to do is put your compass point there, extend it to 1.5 and draw a perfect circle. My circle will be far from perfect, although that's certainly better than I was hoping for. That is approximately what your plan view should look like. Okay, so we want the volume of the cylinder. Now the volume of any three-dimensional, the volume of any prism is its cross-sectional area multiplied by its height. Now for a cylinder, its cross-section is a circle, so it's going to be the area of this circular face multiplied by its height, which in this case is 1.25. Now the area of a circle is pi r squared, so the formula for the volume of a cylinder is pi r squared h, although I've kind of shown you how we can derive it. Now pi is 3.14, so it's 3.14 times by 1.5 squared, so times 1.5 times 1.5 times by 1.25, and that comes to a total of 8.83125, and we want one decimal place, so we're interested in the second decimal place. It's less than 5, so that will round down to 8.8 cubic meters. Okay, so for this question we know that the surface area is 4 pi r squared, so 4 times pi times the radius. Now since we want the glitter per square meter, I'm going to turn this into meters by dividing by 100. So times by 0.6 times by 0.6, and that comes to 4.5216 square meters. Now we need 300 grams for every square meter, so if we've got about 4.5 square meters, we need to multiply this by 4.5. So 300 multiplied by the 4.5216, and that comes to 1,356.48 grams. Now every bottle has 254 grams, So how many bottles do we need? Well, how many 254s go into this number? So we're going to take that number, 1356.48, and divide by 254, and we will get roughly 5.34. It's closer to 5 than 6, but if we only have 5 bottles, 5 times 254 grams will be less than this amount here. So we're going to have to go up to 6 bottles. Just means we're going to have a bit of glitter left over. Okay, so for part D, we've been given this formula, and we want to get D as close to 2.15 as possible. Now we've got two options. We've got a beam angle of 19, or P is a beam angle of 19 and Q is a beam angle of 26. So we are going to use 19 and then 26 with this formula. So using 19 is going to be 19 multiplied by h, which is the height, 5.6, times by 18 over 1000, and that comes to 1.9152. And if we replace the 19 with the 26 and divide all of that by 1000, what do we get? We get 2.6208. And the question was, which one gets us closest to 2.15? 2.15 is much closer to 1.9152 than it is to 2.6208. So that is the beam with a 19-degree angle. So therefore that is spotlight P. Of course, all my working should have been in this box, of course. Okay, moving on to E, which I've just skipped past. So the total width needs to be 3 1/5 times. Actually, we don't need to read any of the waffle. It's just what is 3 1/5 as a decimal? Well, 1/5. That's not so easy to write as a decimal, but if I convert it into 2/10, it's easy writing tenths as a decimal. 2/10 is 0.2. So 3 1/5 is the same as 3 2/10. In other words, it's 3 and 0.2, and 3 plus 0.2, well, that is just 3.2. Okay, so on to, I believe this is the final question. So we know that 3 1/5 is 3.2. So the width needs to be 3.2 times the width of the stage front. So that is 10 times by 3.2, so 32 meters. So what we've got here is a stage front which is 32 meters across. Now it's 5.6 meters high, but we've been told here that the length needs to be 5.8. So we need enough fabric to cover 32 meters by 5.8. Now the fabric comes in strips of 1.4 meters. So how many 1.4 meter strips would it take to take me to 32? So what is 32 divided by 1.4? 32 divided by 1.4 is a fairly nasty number, 22.8, but we can't have 0.8 of a piece of fabric, so we're going to have to call that 23 widths of fabric. Then the number of widths of fabric has to be a whole number. So that is 23 widths, and each width is 5.8 meters in length. So we need 23 strips times by 5.8, and 23 times by 5.8, that comes to 133.4 meters, and that is our final answer, 133.4, and that is the end of this particular assessment.